Why? Because it was quite interesting. There are a lot of things already presented. For that reason, I go directly to 2 slides. One, energy transformation. There are quite challenging things that we would like to achieve before 2050. Means limit long-term temperature rise, achieve net zero CO2, something really clear to everyone, and switch from fossil fuels. I show to you this slide. That is what our CEO said about our objectives in Veolia. Ecology of solutions, bring innovation on the transformation, accelerate our local and decarbonize our energy production, and decarbonize all of our activities. Just to show to you how there are a sort of correspondence between the target that we would like to achieve and our objectives. I go fast on this one. Talking about green hydrogen, I cannot enter into the discussion of the colors. Source, renewable energy. Production, H2. Together with the CO2 capture, we can transform in green ammonia or synthetic fuel. We are concentrating on this field to use into the hard-to-abate industry, steel, refinery, chemicals, or into the big transportation, means heavy transport, ship and aviations. Everything is clear, everything is already decided? Absolutely not. We start 5 years ago to enter into this market as Veolia, to investigate what does it mean, what is our technology, if our technology can be used inside of this new sector. Future is still very vague. Limited amount of renewable energies means there are some challenges and limitations. One of the main points for us is the high cost of the green hydrogen. It's still too high. The other point is water. Water is an important issue. We discovered that something that was perfectly clear this morning. There is an overlapping of the areas where solar and wind is available and water scarcity area. For that reason, we need, for produce the right quality of the water, focus our attention to use all type of waters. Seawater, wastewater, groundwater. For that reason, we are concentrating on that with an holistic approach. This figure was already quite clear, but just to simplify, I use some simple numbers. 10 kilos of DI water is needed to produce 1 kilo of hydrogen. At the same time, we produce oxygen, 7 kilos of oxygen. We use 50 kilowatt-hour of electrical energy. We have extra heat, as is perfectly presented before. We have more than 1/3 of this energy that we are supposed to exchange. We call waste heat. But if we need, for big plants, to use cooling towers, we need an extra 30-40 kilograms of makeup water. It depends on the cycle of concentration, it depends on the source. We start 5 years ago with the idea of investigating, asking with the voice of the customer, the big players, what they need from us, from the support of Veolia. And after this investigation, we received 4 points. Water source flexibility. I would like to be able to use all type of waters. Package solutions, energy recovery, and service support. Be careful. This installation is all over the world in really remote areas. For that reason, the service is extremely important. That was why Veolia was supporting with the presence worldwide and with 3 points: expertise, segmentation of our offer, and global service. I go directly to the simplified slide. We try to analyze what happened inside of the gas and water section, more close to the electrolyzer. More close means norms and specification for the constructions, explosion proof and so, was requested. More far we are from the electrolysis, more standard unit we can use. On that section you can see the applications where we have on the PEM water polishing with EDI or mixed bed, and the technology that we have available in our portfolio. Gas purification, deoxygenation and dehydration, makeup water deionization, and this is the argument of today, with thermal desalination or membranes, RO, plus EDI. Even the intake water treatment is a combination of the different technology, membrane filtration, RO, membrane desalination, clarification, biological treatment, disinfection, I cannot list all. Cooling tower with filtration, blow down reuse, chemicals, and wastewater treatment means we would like to reuse as much as possible the water, even for brine and water reuse, or finally into the zero liquid discharge programs. All these technologies are available into the group. What does it mean segmentation for us? Means we start years ago in a really, really small application. Means segment A is less than 1 mega. Small pilot plants, small refueling station. When I say 1 mega means the power installed on the electrolyzer. Always talking about green hydrogen. In that case, we are offering a package box because the heat is normally extracted with an air cooler. Package box is put inside of a container. As you can see, there is the air cooler on the top, and inside of this box there is, we treat normally tap water, and we put one box inside of this container. Then we enter into the segment B, means small plants between 1 to 50 megawatts installation. In this case, we have a package, in container package solution. We have to treat the makeup water. Sometimes we are using the cooling tower and we need to treat even the water for the cooling tower. We have package plants for the gas separation and for the polishing. All these kind of things, I show you later what does it mean, is in package forms. As soon as we enter into the request for large plants, means into the size of giga plants, we are talking about bespoke solution, means tailor-made plants. We are talking about, for 1 giga, we are roughly talking about 1,200 cubic meters per hour, just to have an idea. In this case, we start with our branch on the desalination to think about thermal. Why not using this extra amount of energy that we have available to produce distillate water? This is in short, what does it mean for us? RO in package, EDI in package, deoxygenation, dehydration in package. Even the water conditioning is part of this standardization. If I correctly remember, on Tuesday we have the presentation of this new RO membrane desalination that we patent as a barrel. Is a new patent solution. As you can see, we try to reduce as much as possible the service, the safety, with this system that include everything. We reduce dramatically the numbers of the connection at high pressure. And we have a plug-and-play outdoor installation, less maintenance, 25% space saving, and modular up to 50,000 cubic meters per day. That is our way how to approach the standard systems. Then we have an alternative means. Why not using this thermal heat? How? Using two. We have a technology of multiple effect distillation to use the seawater, and mainly on the seaside installation, to produce the quantity of the DI water necessary for the electrolyzer, plus all the water that is needed into the global plant. This is in short and really simple schema. Means we pump the liquid at 70 degrees, 80 degrees inside of the boiling chamber. We pass through a tube heat exchanger. We spray the seawater on the top. The vapor is passing by the demister. We condensing with the recirculation of the seawater. One effect, two effect, three effect, depending on the temperature of the seaside, depending on the installations. Schema is simple. Not so simple is the realization, because we use one of our business unit that has developed the desalination through MED. It's called entropy. The solution, as you can see, the path of the vapor through the demister is quite complicated. The other point is the material, because we are talking about high salinity, and even the components, because it's supposed to be put even on the offshore installation. I show you this. This is one containerized solution 40 feet with everything included, means storage of the distillate water, seawater filter, startup heater, production, and EDI. Complete in this 40 container has a capacity between 70 to 120 cubic meters per day, and has the right size to cover the capacity of one turbine. The turbine on the wind turbine between 15 to 25 megawatts. This is what we offer at the moment on the North Sea installations. Then we have modularized even a little bit bigger solution, means solution between 50 to 100 mega is already proposed as a package solution. Skid mounted, 40 cubic meters per day capacity, 2,400 cubic meters per day capacity. The second one, we are in this range. As soon as we enter into the giga plants, we have the bespoke solution, big plants. We have already realized that one. Not for the, at the moment, not for the hydrogen, but certainly for the desalination. I left the two presentation of Veolia at the end just to show to you who we are. We are a company. The group is working on the water, waste, and energy with 220,000 employees, and has a division, a water technology division, dedicated only on the technology, that after the merge with Suez, nowadays it represents 15,000 employees, 4.5 billion euro as a turnover. But what is important is we are present all over the world. Here in Egypt, we have one dedicated operative business unit that is here on the booth, and is extremely dedicated to the hydrogen sector. Last one, because you are asking probably the reference. This is what we are today. 750 small units installed, already installed, mainly in Europe and United States, for the segment A. Means all these units are small box like this one, capacity in the range between 100 to 200 liters per hour, with the sensor and with the remote control. Means we can collect all this data from 750 units in operation. We are already moved toward intermediate plants. We have 30 package plants sold, size between 1 to 10 cubic meters per hour, always into the water section. Into the complex plants, we are participating at roughly 100 projects. 40% of this one has already the solution with the thermal or membranes for the desalination. And we have closed 5 big plants at the moment. 3 of them was in Europe, 1 in the United States, and 1 in Australia. Just to give you an idea where we are now. And that's all.